myself Dr. Ankur Singhal, Professor in Electronics and Communication Engineering Department of Chandigarh Engineering College, Landra, Mohali, Punjab, is here to give a lecture on the subject Multimedia Communication System. First of all, we need to understand what the word Multimedia Communication System is. Multimedia. Multi means many, media means ways of representing the information. So we can represent our information in 4 ways: audio, video, text or image. Like at the moment I am giving my information in the form of a speech signal. So this is an audio. So multimedia is multiple ways of representing the information. Now this information need to be transferred from one place to another over the network. So that is multimedia communication system. That information by representing multiple ways can be transferred from one place to another. Now the major challenge in multimedia communication system is, as our world is growing digital, so we need to transfer our information from one place to another. So security of the information is a major challenge in today's digital world. So today's topic is related with information security, how we can secure our information under multimedia communication system. So I'll be covering network security so that our information remains secure in the network. These are the contents which I am going to cover in today's lecture. Briefly I will give you the introduction, then the cryptography, then algorithm types and modes. Then I will conclude and I will tell you the references which from where I have collected all this material. So first thing is introduction. Now as I said, in today's digital world, a very major challenge is security, information security. Because a lot many hackers and crackers are there in the network which tries to steal the information. So our major challenge is to secure our information so that our information cannot be given to unauthorized people. So our information should be only accessible to authorized users. So what is network security? It consists of policies so that we can prevent and monitor unauthorized access of information in the network. Now there are various ways through which we can prevent network security. One of them is what we can call it cryptography. So now next I will be giving you the model of network security. See, this is the model for network security. Now see, this is the model for network security. See, sender which want to transmit some information, they will transmit over to the channel. This is the channel where the opponent is. Always the opponent, the hacker or the cracker will try to steal the information through this information channel. So how we can avoid that? For that what we need to do, the sender will generate the information which we want to transmit. That will be transformed to some unreadable form, some secret message, so that nobody can read or can understand the meaning of the information. So that is done through some secret information which helps in transforming the information, information which the sender want to transmit into a secret message, a secure message. Now this secure message will be transferred over to the information channel, and at the receiver side the reverse operation will take place, because the sender and the receiver are the authorized users. So at the receiver side we do the reverse transformation. From secure information we convert into the original information. Say for example, I will just give you an example over here. See for example, say if we want to transmit Ajay, this is the information which the sender want to transmit. Will do some key will be used. Say key is 1. Will convert into some secret message. So A is converted to B. Say J is converted to say K, B, Z. Now this is the information which the sender want to transmit, and this is the secure message we transmit over the channel. So as you know, the information is converted into a secure message. So it is unreadable. Any hacker will not be able to understand the real information until and unless he has the key, one key. So this is the basic mechanism which we are going to study for network security. Now the technique employed for network security is cryptography, which is, as I said, it is an art and science to secure or to encode our messages to make them non-readable. Now cryptanalysis is again a technique to decode back the message. See, encoding is done at the sender side, decoding is done at the receiver side. So cryptology is a combination of all above two terms, cryptography and cryptanalysis. Now we basically in cryptography we employ the method of encryption and decryption. So what, as I said initially, what we have done, see the message which the user want to transmit will be converted with the help of some key, and we get a cipher text. See, the message which the user want to transmit, we call it a plain text. So this is our plain text. Okay, when it is converted with the help of the key, we get what we call it cipher text. So this is the cipher text, this is the cipher text. Now at the receiver side, just the reverse operation will take place. From cipher text we convert into plain text with the help of the key. With the help of the key, this is the key. We have denoted encryption key KE and decryption key KD. Now depending on if the same key is used at the sender and the receiver side, then that type of a mechanism is called symmetric encryption. If both the keys are different, then such type of mechanism is called asymmetric encryption. Now this is the message, as I said. Say for example, we want to transmit cat. Cat is the information which the sender want to transmit. We convert it into some other form so that it becomes unreadable. So we are using the algorithm is substitution. We are converting cat with key 1, we get DBU. So this is the plain text and this is the cipher text which we get. Okay. So two mechanisms under encryption and decryption, symmetric and asymmetric. Now see under encryption and decryption, we need to study two mechanisms which are used for encryption. One is what we can call it algorithm types, the other is algorithm modes. Now algorithm types is how we generate the cipher text from the plain text. I think till now the concept of plain text and cipher text is clear. So how we are going to convert from plain text to cipher text? That is, two methods are there. One is stream cipher, the other is block cipher. So see, this is as I said, we can categorize the algorithms into cipher text or block ciphers. Now this is how stream cipher works. It encrypts one bit at a time. It encrypts one bit at a time. Say for example, our data is 10. Say for example, our data is 101. So it is going to encrypt first bit, then second bit, then third bit. It is one bit at a time. So it is quite time consuming. No doubt for encryption you require the key. So plain text plus key we get the cipher text. But the problem with stream cipher is it encrypts one bit at a time. Now next type is block cipher. As the name itself suggests, it encrypts on a block of ciphers. Instead of one bit at a time, block can be of size of 4 bits, 6 bits, 8 bits, 64 bits, 32 bits and so on. Okay. So this is a block cipher. Now the basic mechanism on which cryptography, concept of cryptography lies is confusion and diffusion. We need to confuse the hacker. So as I said, we need to convert the information to some unreadable form. So that is what we can call confusion, and diffusion is spreading of the information to multiple rows and columns. So that can be done by transposition. So now there are multiple mechanisms for this. Basically this cryptography is not a new technique. It was done from medieval times. So the earlier algorithm we called it traditional ciphers. Those are character oriented. Now the modern ciphers are bit oriented. Now the example of traditional cipher is shift cipher technique or substitution cipher technique. In that, one character at a time that is substituted to some unreadable form. I think already I have told you, like A will be replaced by D, B can be replaced by E, and so on. Now in this there are two techniques. One is what we can call it monoalphabetic, the other is polyalphabetic. If the key will remain same for all, then that is monoalphabetic, otherwise it is polyalphabetic. I'll give you an example to understand the difference between monoalphabetic and polyalphabetic. Say for example, A, B, C, this is the plain text which we want to convert into ciphertext. If the key remains same, then what? A will be converted to B, B will be converted to C, C will be converted to D. So this is the ciphertext what we get if we are using monoalphabetic. But if we are using polyalphabetic, then say for example for A, B, C, the key will be different for every character. Say for example A comes first in the character set. So the key will be 1 for A, B because this is its position is second. So it will be key will be 2 for C because it is the third position. So the key will be 3. So it will be converted like B will be shifted to 2 places, C and D. C will be shifted to 3 places, C, D, E, F, C. Now this is the difference. If we are doing polyalphabetic, and this is if we are doing monoalphabetic. Okay. So I hope this mechanism of substitution is clear to you. Now another mechanism is what we can call it XOR. XOR means like I'll give you an example. Say for example input is 101 and the key, this is the plain text, the key is for example 001. So the output will be 110. We'll use the concept of XOR. So 1100 101. So this will be the ciphertext. So again in this way we can convert from plain text to ciphertext using XOR. So these are different techniques for what we can call it encryption. Now some other techniques is permutation and transposition. Permutation, transposition means will shift their position. Say for example, see in this over here 101, say for example. Now 1 is shifted to third place, so 1 will come over here. 0 is shifted to the first position, it will be 0. And this 1 will be come to the middle. So 101 is our plain text and our ciphertext will be 011. So again this is a concept for permutation and transposition where we change their position. Okay. So this is another method for changing the plain text into ciphertext. Now likewise there are different types of permutation transposition. One is what we can call it compressed permutation. In compressed permutation the input is of 3 bits, output can be 3 or 1, 2 or 1, means 1 bit, minimum 1 bit less than the input. In expanded permutation, as the word itself suggests, expanded, will expand the input. Say if the input is of 4 bit, output will be minimum of 5 or more than 5 bits. So this is again one of the mechanism through which we can change the plain text. Now one of the very popular algorithm which is used in cryptography, I'll try to introduce you with the concept of that algorithm, in which all these techniques which we have just studied, substitution, permutation, transposition, XORing, all these can be used or multiple of them can be used. So this is very popular algorithm which is used in cryptography, that is what we can call it data encryption standard, DES. Now see in this, this is a concept, this is an example of block ciphers. See, remember initially we have studied that there are 2 types of ciphers, stream cipher, block cipher. This is a type, this is an example of block ciphers, where the input is of 64-bit, output ciphertext is again of 64-bit, but in between there are 19 different steps through which it need to pass on so that plain text converts to ciphertext. Now the first step is transposition. So what is transposition? As I think already I have told you, transposition means changing their location. Say for example 101, it can be we can take its transpose and it can become to 101. So this can be the input and this can be the output. So we take the transposition, we convert from columns to rows. So first position and 19 position, we do the transposition. 2 to 17 is complex operation. So what is that complex operation? We will study. And for that, no doubt, when we need to convert from plain text to ciphertext, always the key is required. So key is basically 56 bits, but we convert this 56 bits into 48 bits. So basically the key we use is of 48 bits. Now we need to study what the complex operation between 2 and 17 will be. So that we'll see just. Now see, this is one step from 2 to 17. The step will be same, but it will be done, it will be repeated how many times? 2 to 17 times. Means a total 15 times. So what we are doing, input is, input is of 64-bit. We divide this 64 into two blocks of equal size, 32-bit and 32-bit. Now this 32-bit is converted to 48-bit by expanded permutation. I think already I have explained what is expanded. The input can be less number of bits, output will be more. Now 48 bits will be XORed with the key. In the last step I have just explained, the key will be of 48 bit. So 48 bits will get a new output. Now this 48 bits again will be used, compressed permutation will be done. Compressed, as I have already explained, compressed is just the reverse of the expanded permutation. So in compressed, instead of 48 bits, it is 32 bits. Now again we are going permutation, state permutation. We change their bits, we change their position. So what we get, again we get a new output, that is 32 bit. Now this 32 bit will be XORed. For XORing, these 32 bits will come over here, will XOR this and this bits to get a new 32 bit. Now this 32 bit is again brought into the left hand side, and whatever the output of this is brought down, and both are combined so that we get 64 bits again. So input is a 64 bit, output is 64 bit. This complete step is done in what we can call it data encryption standard, and this is one part of complex operation from 2 to 17. See how many times this your plain text will be converted to ciphertext, and then again ciphertext will be converted to another ciphertext. We are basically making it foolproof so that nobody can be able to reverse the operation, so that they can come to know the plain text. We want to avoid that. Okay, I think this is clear to you. Now next we need to, this is a one step of one example of block ciphers. As I said, there are multiple more examples of block cipher algorithm, like data encryption standard, triple data encryption standard, that is one more. One is AES, that is advanced encryption standard. So likewise, I have just tried to explain you one of them so that you can understand what is the problem with block cipher. Now the problem with block cipher is that they repeat itself. The information is repeated itself. I will just explain in the next slide. So just try to understand over here that the information is See, information is repeated again and again. So if the hacker is able to reverse the operation and is able to know the plain text, then he will be able to break all the ciphertext. So that is a problem with block ciphers. So what is it? We'll try to understand in the next example. And I think already I have told you what is the problem with ciphertext. Ciphertext, that it encrypts 1 byte at a time. So it is quite slow. Okay. So instead of encrypting 1 byte, we want it to be encrypted on a block of data. Okay. So now, as I said, there is a problem with the block cipher. Now what is the solution? I'll tell you what the solution is. Now we need to study various algorithm modes which can help you in avoiding this problem. There are 4 types of the methods or modes. One is what we can call it electronic code book, cipher block chaining CBC, cipher feedback mode CFB, and output feedback mode OFB. So we'll try to understand all these in detail. Now this is an example of first type of mode, algorithm mode, that is called electronic code book. Now see, now in this what we are doing, that the plain text is, say for example 5. We are encrypting with some key and we are getting the ciphertext, say for example VF6, VFA3. Now in the next, say the plain text is by, we are encrypting, we are getting some other ciphertext. But say again, if the same plain text comes, because the key is same, we get the same ciphertext. See, compare this with this cipher and this cipher. Same ciphertext we are getting. If the hacker is able to decode this, then if the hacker is able to decode this, then easily he can decode this also. So that this is the problem of repeating text. If the same text repeat itself, then the ciphertext will be same. That is the problem with what we can call it block ciphers. And this is the same problem which repeat in the electronic code book also. Now what is the solution? See, now the solution is, now coming to the solution. Now the solution is cipher block chaining mode CBC. Now in this what we do, see in this what we are doing, that the plain text is say 5. First of all we are XORing. We have introduced one more step than the previous one. What we are doing, we are XORing with initialization vector. This is what we can call it, initialization vector. This is some random number. Any random number can be taken for this. Now first we are doing XORing before encrypting with the help of the key. So we are getting some ciphertext, say VFA3. Now say again we are using the same example. So by again we are XORing with the initialization vector. Now for the next step, initialization vector will be the ciphertext of the previous step. So this will be the initialization vector over here. So we get some ciphertext. Now in the third step, what the plain text is 5. The previous step ciphertext will be taken as a initialization vector. That will be XORed and then it will be encrypted with the help of the key. We get some ciphertext. Now what the thing which we need to know is that see this one and this one. The plain text is same 5 and 5, but the ciphertext is different. In the first it is VFA3, say for example, and in the next it is $Z8Z. Now see, in the previous one, if the plain text is same, the ciphertext is coming same. But over here, even if the plain text is same, ciphertext is coming different. So that is the solution of repeating text. So the hacker will not be able to easily decode this type of a technique. Okay. So basically, as initially I said, we need to confuse the hacker. So we are trying different methods so that we can confuse the hacker. Now likewise, next is what we can call it cipher feedback mode. Again in this what we are doing, see in the previous step if you remember, we are XORing the initialization vector. But over here we are not XORing. We are not XORing. First of all, we are using the initialization vector. We are encrypting that with the key. We are encrypting initialization vector with the key. Whatever the output we get, then we XOR with the plain text, and that will be taken as a ciphertext. Now rest remains same. Next, ciphertext of the previous will be used as an initialization vector for the next step. Again, the key is encrypted. Output is XORed with the plain text. So likewise, again, we are just trying to confuse. We are just trying to use a different method so that the hacker don't able to understand. Okay. So this is what we can call it a cipher feedback mode. Only the difference between previous and this is that in the previous, initialization vector is directly XORed. In this, first initialization vector is encrypted with the key, then it is XORed. Okay. And the last method is what we can call it output feedback mode. Now again, this is a small variation in the same example. Now see, now what we are doing in the previous, we are encrypting the initialization vector and the key, same as done in the last. Then the output of this is XORed with the plain text. Nothing is changed in this step in the previous one method and this mode. But what, if you remember in the last, ciphertext is used as an initialization vector for the next step. Now in this case, ciphertext is not used as initialization vector for the next, but the encrypted output is used as a initialization vector for the next step. This is the change. Okay. So these are 4 modes which we have studied today. One is ECB, CBC, OFB, CFB. So these are the 4 modes which we have discussed today: ECB, CBC, CFB and OFB. Only the thing what we are doing, we are trying to confuse the hacker. Okay. Now moving on. Now I'll just like to conclude my lecture with this, that in today's digital world where everything is going digital, we need to secure our information. That is very, very vital in so many applications, even in banking, in all the transaction, it is very important. So what we want to secure our information from hackers, from unauthorized users. So that can be done with the help of what we can call it cryptography, and we need to understand cryptography in detail. Today we have discussed about symmetric cryptography, stream cipher, block cipher, the problem in the stream cipher and block cipher, and how we can overcome those problems. So that we have tried to understand from this today's lecture. Thank you. And now in the last, the references. I have taken all this material from these references. You can go through these references for more information. And in the last, thank you so much for patient listening to my lecture. I hope you must have understood the concept of information security. Thank you once again. Thank you.